Hi, welcome to this Open Security Summit session in November 2021, where we are going to be looking about, how to use an open source tool and a technology that these guys have been developed to basically do something that anybody who's dealt with Kubernetes knows it can be quite painful, which is how to connect to it, how to access, how to get data, how to make it so that you have a nice and secure way and scalable way to manage your identities and to connect to your resources. So over to you.
Okay, hello everyone. In today's session, I'm going to talk about using Teleport to secure SSH and Kubernetes access. So I prepared this talk to give you a brief introduction about Teleport, the access control features it supports that can be applied to both SSH and Kubernetes access. And then I'm going to show you a short demo on how some of these access control features can be used on case that would help achieve secure access to manage secure access to your infrastructure. So who am I? My name is Saksham Shah. I am developer relation engineers at Teleport. Before Teleport, I have 8 years of experience exclusively in cybersecurity. Worked on both offensive and defensive side, doing pen tests, red teaming, security audits, and also building bespoke cybersecurity products for enterprises. Besides cybersecurity, I love talking about new technologies and startups. And although I'm not that much active in social accounts, so you can ping me in either GitHub, Twitter, or LinkedIn. Here are my handles to all of these mediums. So first, what is Teleport? For those of you who don't know what Teleport is an open source project. We call it Unified Access Plane. It is a single solution to allow you engineers and security professionals to unify secure access to SSH servers, Kubernetes clusters, web application, databases, and desktop environments across all assets in your infrastructure. So what brings Teleport to access management? So the base core part of Teleport is it's based on certificate-based authentication and access control. So it entirely eliminates security risks that are related to using password-based access control. So no credential leakage, no password leakage, no use of insecure passwords. And also certificate means it also eliminates risks of using private keys to manage secure access to infrastructure. So although private keys are way better than passwords, but still private keys hold risks of managing access to user in situations such as what happens when authorized user leaves your company. So what happens, authorized keys is leaked in data breach, and you want to stop anybody to misuse that keys across your servers. So it's somewhat easy in situation where you have 2 to 3 servers, but in situation where you have tens or 20s or even hundreds of servers, then it's really hard to rotate private keys around your servers. So scoped certificates help you eliminate all of those risks and allows you to manage secure access based on user identity. That can be also attached to identity providers such as Okta or GitHub or any providers that supports OIDC, SAML, and such. Next, Teleport supports role-based access control. So having this feature, Teleport allows you to manage access depending on what role the user is required and possesses in your infrastructure and in your company. So for example, a developer only needs to access resources that the developer's day role requires to access. And for example, a junior developer might not need a root access to production servers. So role-based access control helps you define such boundaries within your infrastructure, such that only the user that are required to access servers or services are actually authorized to access those services. Next, Teleport supports complete session recording and replay. It helps. So whenever any security incident happens or during security audits, so it helps to replay what the authorized users actually did in their authorization. So one of the challenges in cybersecurity is insider threats, or even any employees misusing their credential to act maliciously inside the infrastructure. So session recording and replay helps you resolve in situation where any users, employees go rogue, or in any security audits events. Next, Teleport also supports access requests. So access request helps you implement least privileges and just-in-time access. So in many situations in production infrastructure, users are not required to have a continuous 24-hour access to those servers. An access request helps you implement control that would allow any users, if required to access your infrastructure, they would need to request, give a context to what are the reasons they need to access server or services. And administrator can view that context and either approve or deny access to the infrastructure. So Teleport integrates with any ChatOps platform such as Slack, PagerDuty, or you can also use Teleport API to develop your own custom plugin to implement access requests. Next, Teleport has also, apart from the certificate-based authentication, role-based access control, session recording and replays, Teleport also supports dual authorization that is related to access requests that we presented earlier. Teleport also supports, allows you to define role templates that can be used to assign policies dynamically to users who would access your infrastructure. Teleport allows you to impersonate another user such that you can use these features to create short-lived certificate that will be that can be applied to CI/CD, so that you don't need to provision actual credential for users in cases that will be deployed in public infrastructure such as GitHub Actions, GitLab CI. And by default, Teleport also supports second factor authentication, so you can enforce another layer of access control on top of existing certificate-based authentication. Teleport also supports privilege per session multi-factor authentication. So for mission critical servers, so users enforcing these features will require user to perform second factor authentication every time they initiate new session. And lastly, Teleport supports session and identity locking. So these features is one of the useful feature in cases such that what happens if you identify a user is acting maliciously in already authenticated session, or you find that a user credential has been misused to access your infrastructure and you want to block access to that servers. So rather than you blocking access to entire fleet of your servers, you can just implement session locking and block access to particular server or service that the malicious user is using, so that you can avoid downtime to your infrastructure, and yet you can successfully block the malicious access. So these features collectively helps you implement secure access to your infrastructure via SSH or Kubernetes. So how Teleport works behind the scene. So at core, Teleport is the Bastion server. So users that will be connecting to your infrastructure from either public network or even from inside corporate networks, so they will use teleport web UI or teleport SSH clients such as TSH or kubectl, and they will authenticate with teleport authentication server, which can be integrated with your identity providers. And upon successful authentication, teleport will issue a scoped certificate, which can be used to access SSH servers, Windows servers, Kubernetes clusters, databases, or internal applications such as Grafana, Jenkins, GitLab. And depending on the access control features that are implemented, users may require to request for specific access request via that will be notified to administrator via chat or platforms such as Slack, Mattermost, etc. And depending on the context, administrator can approve or deny access. And similarly, user will be allowed or disallowed to access infrastructure. So this is collectively how users will access infrastructure when teleport is provisioned within their infrastructure. So I'll be presenting a demo on 3 of use cases at how users you'll be enforced and will be required to go through teleport or will be controlled via teleport features. So first demo I'm going to give is that would cover teleport RBAC. So this demo will cover enforcing RBAC to SSH using teleport. So in this scenario, what we have here is a Linux server, and we have a developer who accesses this Linux server frequently. This Linux server is configured with both root and non-root users, and the developer accesses this server frequently as both root and non-root users. But this developer doesn't require to have access to root account. So what we'll do is require this developer to access Linux server via teleport, where we can control such that root access will be blocked and every non-root access will be allowed. So let me just switch back to my desktop. So here I have admin interface. So this is a web UI of teleport, and at this workspace, so I have a. So this is I'll be demoing in this workspace. I'll be demoing as a developer user, and in this workspace, I will be using admin interfaces to configure teleport. So just to give you a quick demo on this is developer account, and the developer user can access Linux server both as root and non-root users. So just to give demo on accessing server as a root user. So the developer can easily access server as a root user. And developer can also access the Linux server as a non-root user. So what I will do is create a developer account in teleport and configure the account such that user can access only as a non-root user. So first, let me create a developer account. Users and developer and roles access. This access is a predefined role in teleport that would allow users to access resources. If this role is not assigned to a user, even they have a teleport account, they would not be able to access servers. And then we'll also require to provide a login name, which users can use to access the server. So here we are providing non-root as a username, as a login name that this user will use to access the Linux server. So if we would like to allow this user also access as a root user, so in that case, we would be also allowing root login name. So, oops. So here I've created users using TCTL tool. It's a command line tool available with Theraport that helps you issue commands to administer Theraport. So I'm going to copy this link and send developer a message that would require him to complete the user setup process. Hi, developer. Here's a link to for Theraport. So as an administrator, I've created a developer account and send a message to developer that he will be required to sign up to Theraport and use Theraport to access Linux server. So in the meantime, I will also configure Theraport node that will that will add Linux server as the SSH node to Theraport, so that Theraport can proxy SSH request to Linux servers. So next, I'll issue TCTL token add type node. So here's the invite token. That will be used to connect with Teleport cluster. So here, so I've already initiated SSH access to Linux server as an administrator. So in this window, I'll start Teleport. Teleport is already installed in Linux server as well. So next, what I'll do is connect this server to Teleport cluster. So here is the predefined command I had already entered. I just need to replace the token. So the command is teleport start with the role node that would allow this Linux server to connect to Teleport cluster. The web URL of the demo Teleport cluster I have hosted is primary.teleporters.dev, and it will require token to join the Teleport cluster. So after issuing this command, so this server is already connected to Teleport cluster. We can also verify this. So this shows, and if it's visible, okay. So this shows that this Linux server is already connected to Teleport cluster. Next, what we'll do is stop the OpenSSH server entirely, so that the developer cannot connect to this server via OpenSSH anymore. So systemctl stop sshd.service. So you can verify status sd.service. So it's inactive. So as a developer, I'll just try to connect to the Linux server again. And you can see the connection is refused. So to access this server, now what I'll need is, as a developer, sign up to Teleport using this link shared by administrator. And complete user registration process. So first, I will be scanning this QR code to enroll two-factor authentication in my Authenticator app. Next, I'll give it a password and log in to 35. So you can see my Teleport my account as a developer user has been created with Teleport. Now, next, to access this server, I'll have to issue TSH login that will allow me to access via Teleport SSH client, which is TSH. TSH login. I'll have to give it a proxy address of proxy server, which is primary.dev, and login as a user developer. So it will ask me for my password, and I'll need to supply my TOTP code. 778. Now I am authenticated, and so this is my Teleport account profile, and I have been granted a role of access, and I can access Linux server or any servers as only as a non-root user. Now, to just give you fine. So I'll show you how I can access this server from the Teleport UI itself. So you can see I can access Linux as a developer user. I can access Linux server as a non-root user. I can issue commands. .com, or even change directories, or and perform apt updates. As you can see, I can issue any command, but I have to go through Teleport and not access directly via OpenSSH. So as an administrator, you can view my active session as well and see any audit logs. For example, a session has been started as a developer account. A developer account has local login, successful login, which I did as a TSH login command. So as a user, I will exit from this SSH session. And so here comes the recorded session. Linux server accessed by a developer account. I can just play and see every command issued by this user. So as you can see, my access to Linux server as a developer account has been completely blocked if I try to access via OpenSSH, but I can still access the server via teleport, but only as a non-root user. So this demo is so now as a demonstration for this part one is completed. It shows that how you can use teleport access control features and role-based access control feature to allow users to only particular accounts and block access to even though the user can access the server, but is only allowed to access the server via a particular role. So the next demo I'm going to give is
so I had a couple of questions. Do you mind if I ask them on that demo?
Sure.
So that environment, right? You had, was teleport running in like a central location, or was he running on the Kubernetes cluster, or this is not Kubernetes at the moment?
So teleport is actually running in a separate Linux server. This is not this Linux server, but a separate Linux server.
Okay, but this is okay. This is not Kubernetes deployment. This is just normal SSH deployment.
Yeah.
Okay, got it. So in this case, you have a Linux box in EC2, for example, or cloud compute that runs teleport, and that's the one that manages, and that's the one that when the server boots up, you register, you give it some credentials, so you register that server into the teleport server, right?
Yeah.
Okay, got it. And then we use that to manage access. And I'm assuming that a lot of this could also happen automatically, right? Like, because if you have machines connecting and disconnecting, part of a CI pipeline, a bunch of other stuff, right? This would also capture that, isn't it?
Yeah. So anything, once the server is connected to teleport cluster, every access is going through to and through that server will be recorded in teleport.
So technically, if that user was actually a CI pipeline, you would also capture that, right? You capture, let's say it was a CI pipeline to build a particular server. You will capture every command that was executed, right?
Yeah, correct. So the CI pipeline will be assigned a separate scope certificate from teleport. And using that scope certificate, the CI pipeline will have a credential that would allow to access the server. So the credential will allow scope roles. And once the CI pipeline credential is authenticated to teleport cluster, so everything that is executed by CI pipeline will be recorded to teleport.
See, that's a really good feature, right? That's very interesting because, especially in this day and age, we're trying to create really strong change of custodies and a lot of mappings. And we have a bunch of, servers that are built as part of a CI pipeline, right? And I like the fact not only you can manage going forward, you can connect that. So you could, in a way, you could deploy servers that have teleport enabled, even if you don't have a teleport server, right? You can only add it if needed, right? Or you only enable
correct. Yeah, totally. Yeah.
Because some of these things, like a lot of times, we don't want access to the server, but if you need to, or need to connect data, it's good to have that process. I think machine-to-machine access is very important because in some environments, the users don't have access to it, but you do connect to the environments to do a bunch of other things, right? And it's really cool to have the logging, even for debugging, right? Even to debug and to understand what happened to the server, right? It seems that you found a great way to capture the history of what was done to the server. And I'm assuming that, if we were running Helm charts, you're capturing all the output, right?
Yeah. Anything run within that shell session will be recorded to teleport.
Yeah, so that's cool, because if you run an upgrade with Helm chart or something like that, then you also see it, right? All right, cool. Great stuff. That was my questions. Now, really good.
Okay, so this is the first demo. The second demo is the use case I will be presenting on enforcing just-in-time privilege to Kubernetes access. So in this scenario, I have a Kubernetes cluster. that's already been created and provisioned. And then I have existing teleport server. And so this Kubernetes cluster is occasionally accessed by a contractor, a demo contractor. So the contractor occasionally requires to access Kubernetes cluster, perform some administrative tasks. So how we have configured teleport and this contractor user in this scenario is that the contractor user account has been already created in teleport server, but is provisioned with a role that requires contractor to initiate access request to administrator stating what is the reason for access. And depending on the context, administrator can allow or disallow access to Kubernetes cluster. So if you look at the teleport UI, so we have the contractor account already created in teleport with roles, access, and contractor. So to also further expand on the roles, how the roles look like is, so for example, this is a contractor role. So contractor role, it's a YAML file spec that defines the contractor role profile. So if you see here, so this contractor has a spec that allows the contractor to request access to a role that is kube member role. And if you see kube member role, so kube member role has the spec that allows any users with this role to access Kubernetes cluster as a system master group. So this contractor is provisioned in such a way that he has access to a role that allows to access requests to another Kubernetes role that is named as a kube member that will allow this contractor to access Kubernetes cluster as a system master role. So the user is indirectly mapped with a role that would allow this user to access Kubernetes cluster, but to achieve that role, user needs to initiate access request. So next, so this workspace here is a contractor workspace. So as a contractor, let me just try to log into teleport cluster. See primary.teleporters.dev user contractor. Let me supply my password and supply my TOTP code 807. So this is my contractor role profile that is printed here. So Kubernetes access for me for this role, contractor role is enabled. This contractor can access Kubernetes cluster that is already enrolled within teleport. So to access this Kubernetes cluster as a contractor, search kube login and kube as. So you can see which cluster is enrolled in teleport, then SSH kube login. So just logged into this teleport cluster via SSH and kubectl get nodes. So you can see that executing command kubectl get nodes is giving error from server. This user cannot request Kubernetes access, has no assigned groups or user. So you can currently see this user account is provisioned to access Kubernetes cluster, but at this time is not authorized. So to access this server, what we need to do is request a role queue member as a contractor account, so that administrator would be able to grant access. So request role Kubernetes cluster user contractor. I may okay. So here my request is initiated. So if I go to for this scenario, I've integrated teleport cluster with Slack. So it's a demonstration of a ChatOps platform that teleport support. So whenever user initiate access request, so you can see the teleport plugin for Slack gives me a message that a user named contractor is asking for Kubernetes role queue member. So to view this access request in detail, so just click the link and it opens up teleport UI. So this is access request UI, where the administrator can view detail of what the user is asking for a role, and depending on the context, and as an administrator, I can either approve or deny this access. So in this demo case, I want to authorize this contractor user to access Kubernetes clusters. So I'm just going to approve this time. It's an optional message, submit to review. So I've authorized this access request from contractor user. So as a contractor user now, you can see my access request has been fulfilled. And so I've been assigned with the Kubernetes group system masters. So now, if I execute this command, I should be able to get nodes that's available in Kubernetes cluster. So this is it. So I was able to get nodes which otherwise would not have been possible without this access request. You can also see here that the access request for this role is valid for 11 hours, 56 minutes. So I can access this Kubernetes cluster until my access request is expired or explicitly been removed. So just let me execute more commands, get namespace. So we have a bunch of default namespace. So I'll just try and demo accessing a Kubernetes pod within this namespace. Stack get pods. So a bunch of pods running. So I'll initiate a shell session here to this pod and anti-exec then SSH. So you can see now as a contractor user, I have full access to Kubernetes cluster, given with this user is authorized with system master group. And I've just initiated a shell session to pod inside a Kubernetes cluster. So I can execute commands, touch test.txt, permission denied, password, like if this user is able to, as you can see, this user has full access to viewing etc password and such. So I'll just exit this session, and you can see the session has been recorded. So this also concludes the part 2 demo of this talk, that a user was able to access the Kubernetes cluster that would otherwise would not have been possible without asking for a just-in-time privilege to the administrator.
And just a question on that one. And in this case, the teleport basically server or components were actually running inside Kubernetes, right? Or also on an external server.
Expanding on that part, so teleport supports installing teleport inside a Kubernetes cluster, or also allows to connect to Kubernetes cluster outside from apart from being installed in Kubernetes cluster. So in this case, teleport is not installed within Kubernetes cluster. So teleport is installed and managed independently outside of Kubernetes cluster. But in this scenario, it is configured in such a way that a service account for teleport is created inside Kubernetes cluster. So that's how teleport is able to manage access via teleport proxy to Kubernetes cluster.
Got it. But this would also work completely offline, right? Like those clusters don't need any access to the internet, right?
It's just that teleport clusters should be able to communicate with Kubernetes cluster.
Yeah. So as long as they can talk, so they can be on a VPC, right?
Yeah.
That gives them access to that information, right? Yeah. No. So the other, again, I to be honest, like one of the areas I'm thinking that this is very, very useful is actually not necessarily the human operator, although I think that's important for some development environments and some situations. But the one I really like is, we already run multiple clusters, right? And to sometimes manage the relationships amongst them and to really lock them down can be a bit hard. And I really like the fact that with this, you can, distribute, short-lived tokens. You can have a whole workflow where even one token, even in the admin cluster, concept of the admin cluster, even when he goes and gets some data from another cluster, you can, very effectively limit its part, right? Because that's sometimes the hardest thing, right? And actually, sorry, another question. In terms of, I guess this is running natively in Kubernetes, right? So you can run this on any of the cloud providers, right? There's no limitations.
Yep. It's not just specific to any particular Kubernetes distribution. So this works any standard Kubernetes distribution. Yeah.
Very cool. Good stuff. All right. Thanks.
Yep. So this concludes the demonstration part 2. So next is the last demonstration for this talk is about session locking, how you can enforce session locking feature to lock out malicious user. So this is in continuation to demo 2. So in demo 2, as a contractor user, I executed some of the commands such as I did a cat to etc password. So that's not what the contractor is supposed to do. And it may deem malicious if that's not the role that contractor is assigned with. So after assigning authorizing contractor, what administrator should do is replay a shell session that was executed by contractor. So let's say this is not what the contractor is supposed to execute inside a Kubernetes cluster. So this user seems malicious, can be a genuine contractor trying to misuse the credential, or maybe contractor's credential have been already compromised. So in this case, what teleport supports is locking access so that this contractor would not be able to connect to teleport Kubernetes cluster, even though the contractor user has a valid certificate and valid credential to access Kubernetes cluster. So as an administrator, what I'll do is execute a command tctl log user contractor for time, let's say, for example, 10 minutes. So executing this command, response will created a log with name. It's a log ID. So this means the locking of user account has been enforced. So as a contractor, I still have a valid certificate, but as a contractor, if I try to access the same pod that I had been able to access previously, it gives access denied. So this lock will be enforced till since the lock was enforced for 10 minutes. So this contractor won't be able to access to Kubernetes cluster or execute any other command as well. So access denied. Access denied. So this user won't be able to connect to any teleport cluster or execute any command to that cluster or any resources that has been protected with teleport. So this way, teleport support session locking that allows users to for any given time for a given period. And for this demonstration, I've used a command that is blocking the whole user account contractor as a whole user account, but teleport supports locking access to individual servers or clusters as well. So this concludes demonstration part 3 as well. So these are the 3 demonstrations for this talk. If you have any question, Denise.
No, this was really good, right? I think it's I definitely want to give it a test drive, right? You seem to have solved a number of good problems, right? That exist, right? When you're trying to manage identities at this level, right?
Yeah.
So it's really cool, and all the stuff you showed, it's all the open source elements of it, right?
Correct.
Yeah. So I think what would be good is also actually maybe let's just see if there's any questions or anybody on the chat. Let me just double check. But I think to be good. Cool. So is that the end of your slides or?
So yeah, so next recommended steps for everyone is go and try Teleport. It's available at goteleport.com/teleport/download. You can read access control docs, more on access control docs that is available in this URL. So how access control for SSH Kubernetes and database and web apps using Teleport. And you can also check out since Teleport is open source project, you can check out Teleport on GitHub at github.com/gravitational/teleport. So this is it, concludes my talk for this event. So if you have any question, I'd love to answer. Yeah.
No, I think